Hi, I'm Prof. Johnny. Welcome to Goodwill Training and Assessment Center Incorporated. May kasabihan tayo na sa Diyos ang awa, na sa tao ang gawa. So ano pa hinihintay natin? Tara na at gawa na tayo! As I promised before, I'm going to make a tutorial video about how to cut a spar gear in a step-by-step procedure. And the gears that I'm going to make will be used as replacements for these gears with broken teeth. So I have to make the gear with exact measurement and tooth profile. And the type of the material to be used is carbon steel 4140. So it's hard material. So let's now begin. The step-by-step procedure in cutting spar gear by the use of vertical milling machine is as follows. First step, calculate all the necessary gear data. So here are the things that we should calculate for the gear data. The outside diameter, which is equal to n plus 2 times the module. The required number of teeth is 45, and I'm going to use module 2.5 gear cutter. So the outside diameter is equal to 117.5 millimeters. So this is a metric gear. Another thing is the hole depth of the tooth, which is equal to module times 2.166. So the hole depth is equal to 5.42 millimeters. And we should also know the cutter number, which is number 6, which is used to cut 35 to 54 teeth of a gear. And we also need to calculate the indexing. I'll be using a Cincinnati standard plate. So the indexing fraction is 40 over 45. I'll reduce it to 48 over 54. So I can use the available Cincinnati index plate with 54 hole circle. So there are 48 holes for every division on a 54 hole circle. Next step, turn the gear blank to the proper outside diameter. Okay, here's now the gear blank with a diameter of 117.5 millimeters. Next step, press the gear blank firmly onto the mandrel. Check that the vertical head is at right angles to the table in both directions. Okay, there are 3 methods may be used to align the vertical head or spindle of the machine. First is aligning the graduations on the head of the machine. The second method is setting the square on the table with its blade against the side of the spindle. And third is by the use of dial indicator. This is the most accurate method, and this is what I'm going to use now. Okay. Perfect. If you notice, I aligned the spindle of the machine on its one side only because the vertical head of this machine can be swiveled side to side only. Unlike this vertical milling machine, in which the vertical head can be swiveled side to side and front to rear. So both the side and front surfaces of the spindle should be aligned. Okay, next step, mount the index head and footstock and check the alignment of the index centers. So here's now the dividing head and its footstock. The dividing head spindle should be parallel to the machine table. Both in vertical and horizontal planes so that the teeth of the gear to be cut will be parallel with the gear axis. But how do we do that? By aligning the graduation on the swivel block of the dividing head to 0. Ayan. But the accuracy of this method depends on the alignment of the index line and the 0 graduation. But again, I want a more accurate method by the use of dial indicator and a cylindrical test piece. Very good. Okay, next is the horizontal plane. Ililipat lang natin dito yung dial indicator. Okay. Very good. Stable na yung pointer. Okay. So, align na both the vertical and horizontal planes of the dividing head spindle. Then, of course, ilalak na natin ang dividing head. Okay, if the footstock is adjustable in height, then it should be aligned with the center line of the dividing head. Okay, perfect. Perfect alignment. Next step, set the dividing head so that the index pin fits into a hole on the 54-hole circle and the sector arms are set for 48 holes. Okay, this is the 54-hole circle of the Cincinnati index plate. It is at the innermost hole circle. And take note, do not count the hole in which the pin is engaged. So let's start counting 48 holes dito sa sumunod sa index pin. Okay. Ayan. So ayan na yung pang 48 holes. Okay? So dapat nakaset na yung sector arm natin dito. At yung isa naman nakabangga doon sa index pin. Next step, mount the mandrel and workpiece, which the large end toward the indexing head between the index centers. So this is the larger end of the mandrel, which should be placed on the dividing head. Then take note, the gear blank should be far enough from the chuck of the dividing head to ensure that the cutter will not hit the chuck when the gear is being cut. Next step, move the table close to the column to keep the setup as rigid as possible. I will now bring the table near to the column of the machine. Ganito rin ang setup natin kahit sa horizontal milling para mas matatag. Okay? Mas malapit ang table natin sa column ng machine. Next step, mount a module 2.5 number 6 cutter on the machine arbor. Okay, so this is the module 2.5 number 6 gear cutter. Step number 10, center the gear blank with the cutter. Sometimes, ganito ang method natin. Ina-align lang ang cutter sa gitna ng pointed part of the footstock o dito sa dividing head. But I have other method which is more accurate. Divide the diameter of the gear blank by 2, then add to half the thickness of the gear cutter. So the gear blank diameter is 117.5 divided by 2 equals 58.75. Cutter thickness is equal to 7.5 millimeter divided by 2 equals 3.75. So the total would be 62.5 millimeter. Okay, so tingnan natin paano natin set up. Now let's perform. Loosen the spindle lock. Then let the bottom surface of the cutter just touches the upper surface of the gear blank. Ayan, dumikit na. Then, lock the spindle firmly. Then move the gear blank along the y-axis towards the column of the machine para lumayo siya sa gear cutter. Now, set the graduated collar of the knee elevating handle to 0. Okay? Now, if the machine is equipped with digital readout, then you can also set it to 0 for the z-axis. Now, I will raise the table up to 62.5 millimeters. Both the graduated collar of the knee elevating handle and the digital readout are set to 62.5 millimeters, which means that the center line of the gear blank is aligned with the gear cutter accurately. Now lock the knee clamp and remove the knee elevating handle so that it will not be moved accidentally and change the setting. Next, start the machine and turn the work beside the cutter. Take note, the direction of rotation of the cutter should correspond to the formation of the teeth. So tingnan nyo yung formation ng teeth. Dapat iikot siya ng clockwise. And another, the feed movement is opposite to the direction of rotation of the cutter. And this is what we call the conventional milling method. Okay? Let's see the direction of rotation of the cutter. It should rotate clockwise. Yeah. Next step, adjust the table until the cutter just touches the work. This can be done by using a chalk mark or blue dye on the gear blank or a piece of paper between the gear blank and the cutter to indicate when the cutter is just touching the work. Next, set the graduated feed collar of the cross slide to 0. Next, move the work clear to the cutter by means of the longitudinal feed handle and move the table by moving the cross slide hand wheel counterclockwise about 2/3 of the depth of the tooth, which is 3.6 or 4 millimeters. Then lock the cross slide. Okay, lagay natin sa starting position. Then mag-feed tayo. Pwede graduated collar of the cross slide or the digital readout, set natin sa 0. 1 mm, 2 mm, 3 mm, 4. Then lock the cross slide. Next, slightly notch all gear teeth on the end of the work to check for correct indexing. Okay, this is for the last notching for the teeth. Okay, may notch na sa lahat ng ngipin. At sure na tayo, there are 45 teeth. Okay? Rough out the first tooth and set the automatic feed trip dog after the cutter is clear of the work. Okay? Since the material is tool steel, we need to use a coolant to prevent excessive heat that may harden the material, causing the gear cutter to get dull easily. lampas na yung cutter natin sa workpiece, iset ko na yung automatic feed trip dog. And be sure na yung rotating cutter ay malayo pa siya sa chuck ng dividing end. Then, step number 16, return the table to the starting position. Then note, clear the end of the work with the cutter. Okay, let's go back to the starting position. Be sure that the cutter is off from the workpiece o medyo malayo na siya sa workpiece para pag nag-index tayo ay hindi sasabit ang gear blank. The next step, cut the remaining teeth and return the table to the starting position. I will set an automatic feed. Now, second to the last cut for wrapping cut. Okay, this is now the last tooth for wrapping cut. Next step, loosen the cross slide, move the table to the full depth of the teeth, and lock the cross slide. Okay, this is now the last tooth for finishing cut. That's how we cut a spar gear by the use of vertical milling machine accurately. Now let's have a Q&A portion. Prof. Johnny, what will happen to the gear if the vertical head of the machine is not perpendicular to the machine table? The exact profile of the cutter will not be generated. Since the gear that I made will be used for the transmission of the machine, it must be heat treated to produce the desired hardness and toughness. And that's what I will be performing on my next tutorial video. So please keep on watching. Thank you very much.